Here we will continue this type 3. Okay, we will take today the refrigerant recovery.
In this module, we will cover various refrigerant recovery methods along with a couple of techniques to expedite the recovery process.
A recovery machine houses a compressor responsible for extracting refrigerant during the recovery process. Water-cooled recovery units are commonly used while recovering refrigerant from chiller systems. Their benefits include faster recovery and capability to easily and rapidly recover large quantities of refrigerant. A water-cooled recovery unit uses a condenser coil which cools down the recovered vapor refrigerant and converts it into a liquid. The recovery unit's condenser coil is similar to the condenser coil in a refrigeration appliance. Local municipal water supply is continuously passed over the condenser coils to cool it. Unlike other recovery machine types, water-cooled units are less prone to overheating, even when dealing with large quantities of refrigerant. They are preferred for their ability to efficiently recover significant amounts of refrigerant in a relatively short period.
What is a typical advantage of water-cooled recovery unit? High pressure at recovery compressor discharge, high pressure in recovery tank, faster recovery of large quantities of refrigerant.
Low-pressure chillers are equipped with a rupture disc as a safety measure. If the pressure during the recovery process rises to 10 to 15 psig or surpasses it, the rupture disc may burst to release excess pressure. All recovery units used for recovering the refrigerant from a low-pressure chiller are equipped with a high-pressure cutout control. This safety feature ensures that the pressure does not exceed 10 psig.
What is the typical settings for the high pressure cut-out control on a recovery unit used for evacuating the refrigerant from a low pressure chiller? Highest pressure is 15. Oh, 10? Yeah. All recovery unit is used for recovering from low pressure chiller have high pressure cut out control that does not allow the pressure does not allow the pressure rise above 10.
It's important to remember that recovery hoses and gauges are connected to the appliance for various purposes, including recovery, evacuation, and troubleshooting. Furthermore, any equipment utilized for these purposes and manufactured after November 15, 1993, must be fitted with low-loss fittings. Low-loss fittings minimize the loss and venting of the refrigerant fluid while connecting and disconnecting the hoses to the appliance's service valves. Self-sealing connectors and hand valves are few types of low-loss fittings. All refrigerant recovery and recycling equipment must be certified and labeled by an EPA-approved equipment testing organization to meet EPA standards. Note that it is not necessary to report the purchase of any recycling and recovery equipment to the EPA.
What is the requirement for equipment used for recovery, evacuation, and troubleshooting purpose manufactured after November 15, 1993? They must equipped with high pressure cutoff control. They must have pressure gauge with high pressure reading. They must be fitted in low loss fittings. They must include additional recovery hoses for redundancy. They must equip with high pressure cutoff control, I think. No? Fitted with, yeah, lowest fittings.
Refrigerant recovery is the process of removing refrigerant from a system and storing it in an external container. It is crucial for technicians to recover and remove the entire or maximum possible amount of refrigerant from the system. During refrigerant recovery, if confirmed leaks are present in the system, it is necessary to drain the water from the condenser and evaporator barrels through the drain valve. It's important to note that the pressure in the chiller barrel decreases continuously throughout the recovery process. The low pressure generated by the recovery machine can draw water from the chiller tubes through leak openings or holes. It's essential to remember that water acts as an impurity when mixed with refrigerant.
What precautions should be taken prior to recovering a refrigerant from a chiller suspected of having tube leak? Drain the water sides of evaporator and condenser. Run the circulating pump. Be certain the purge unit is operating. Open condenser vents. What is precaution should be taken prior to recovering refrigerant from chiller suspected to have leak? Okay, drain the hose side of the evaporator and condenser.
If the system has no leaks and the recovery is conducted for other reasons, draining the water from the chiller tubes is unnecessary. In such circumstances, it's important to keep the water in the evaporator and condenser tubes circulating throughout the process. The water circulating pumps are always responsible for circulating water in the system. During the recovery process, the reduction in pressure leads to a decrease in temperature within the chiller system. Remember, maintaining water circulation throughout the recovery process is crucial for preventing freezing and ensuring the system operates smoothly. In chiller systems, water within the tubes is always kept moving either by continuous circulation or by draining when necessary. Preventing ice formation is crucial because it can lead to damage, such as bursting copper pipes and harming water circulation pumps.
Why must water be circulated through a chiller during the refrigerant evacuation? To speed up the recovery process, to prevent loss of refrigerant, to prevent freezing of water in supplies, to maintain constant refrigeration, to prevent freezing of water of appliance.
The refrigerant can be recovered in either liquid or vapor form. It is necessary to recover both the liquid and vapor refrigerant from the system for complete recovery. Let's discuss this further. During the recovery process, liquid refrigerant is extracted from the liquid line within the system. To expedite the recovery process, the refrigerant is initially recovered in its liquid form. However, it's important to note that due to the mixing of refrigerant oil with the refrigerant, liquid recovery can result in the loss of refrigerant oil. After liquid recovery, the remaining refrigerant is recovered in vapor form. Vapor recovery tends to be slower and more time-consuming compared to liquid recovery. Therefore, to optimize efficiency and save time, the recovery process typically begins by removing the liquid component first.
For low pressure system, refrigerant removal started with liquid removal.
During the recovery process, vapor refrigerant is extracted from the vapor line in the system. Compared to liquid refrigerant, there is typically a lower amount of refrigerant oil mixed with the vapor. As a result, vapor recovery helps minimize the loss of refrigerant oil from the system during the recovery process. An average 350-ton R123 chiller, even at 0 psig, still contains approximately 100 pounds of vapor after all the liquid refrigerant has been removed. Therefore, it is crucial to recover the vapor refrigerant after liquid recovery to ensure complete removal of refrigerant from the system. Tonnage refers to the cooling capacity of an appliance. For instance, we commonly refer to a 5-ton AC unit, indicating its cooling capacity. Atmospheric pressure refers to the pressure exerted by the surrounding atmosphere. In some instances, leaks in the appliance may allow air to enter during the recovery process, preventing complete recovery. In such cases, recovery from the appliance can only be achieved up to atmospheric pressure, as further recovery is hindered by the presence. Note that in the EPA exam, depending on the question, the term evacuation may be used interchangeably with dehydration or recovery in various contexts. Recovery time is the time it takes to recover a refrigerant. Generally, we want to recover refrigerant in the least possible amount of time. Factors affecting the time it takes to recover refrigerant include the ambient temperature and the hose length. A higher ambient or room temperature leads to a faster recovery. The shorter the length of the recovery hose, the faster the refrigerant flows through it. As previously mentioned, liquid recovery is faster and reduces the overall recovery time. This is because the pressure inside the liquid side of the system is typically higher. The elevated pressure facilitates the quicker expulsion of liquid from the system into the recovery tank. In this module, we covered various refrigerant recovery methods, explored the equipment and recovery process, and discussed techniques for expediting the recovery.
Okay, let's go to refrigerant recovery quiz. We have now here 6 questions. What is the typical settings for the high pressure cut out control on recovery unit used for evacuating the refrigerant from low pressure chiller? It will be 10 psig. For low pressure system, refrigerant removal started with liquid removal. What is the typical advantage of water-cooled recovery unit? Higher pressure as the recovery compressor discharge, higher pressure in the recovery tank, faster recovery of larger quantity. What precaution should be taken before recovering refrigerant from a chiller suspected of having tube leak? Drain the water side of evaporator and condenser. What is the requirements for equipment used for recovery, evacuation, or the troubleshooting purpose manufactured after November 15, 1993? They must be occupied with high pressure cutoff control. Yeah. Why must water be circulated through the chiller during refrigerant evacuation? To be speed up recovery process. Okay. Let's submit it and check. Okay, we have 2 questions. Okay, the answer, any equipment manufactured after 1992, so they must be fitted with lawless fitting. Lawless fitting, sorry. Why must water be circulated through the chiller during the refrigerant evacuation? To prevent freezing of water. Okay. The next one is evacuation and charging. Let's check evacuation.
In this module, we will explore the process of evacuating the system. We will also learn various tips and techniques for achieving successful evacuations.
Evacuation involves removing all water vapor and air from the refrigeration system. This step is crucial before refilling the system with refrigerant to prevent mixing with air. It's achieved by sucking out all air and creating a vacuum inside the appliance. A vacuum pump is used to evacuate the system to the required levels. In chillers, the cooling water or moisture from the outside air can leak into the system. Evacuation is the final step to remove all these contaminants before filling the system back with refrigerant that has already been recovered. The required levels of evacuation for low-pressure systems are as follows. 25 millimeters of mercury gauge for equipment manufactured before November 15, 1993. It's important to note that gauge in this context refers to pressure measured above atmospheric pressure. Additionally, most pressure gauges indicate gauge pressure. The required levels of evacuation for low-pressure systems are 25 millimeters of mercury absolute for equipment manufactured after November 15, 1993. Recall that the term absolute means pressure measured with respect to vacuum. When repaired for any leaks, all low-pressure systems and chillers must be evacuated until the specified pressure levels are achieved. After reaching the required vacuum on an appliance, a technician should wait for at least a few minutes. If the system maintains the vacuum level, it confirms that the system is no longer leaking. Before disposing of a low-pressure appliance, it must be evacuated as per the regulations to prevent venting of refrigerants in the atmosphere. The equipment should be evacuated to 25 millimeters of mercury absolute pressure before disposal to ensure compliance with environmental regulations and prevent environmental harm.
Identify the recovery requirements for equipment disposal 25 inches HD of HD absolute.
The pressure and temperature of any system are directly related to each other. A reduction in pressure results in a drop in the temperature of the system. During evacuation, as the pressure decreases, the temperature of the system also drops. This decrease in pressure can lead to very low temperatures, possibly causing water vapor to freeze into ice. If ice forms, it can clog the refrigerant piping, which must be avoided to ensure the proper functioning of the system. Technicians can employ a special technique to prevent freezing during evacuation. By intermittently stopping evacuation and increasing the pressure, technicians can release some nitrogen gas into the system. The nitrogen gas serves to increase both pressure and temperature, thus preventing moisture from accumulating. Once introduced, the nitrogen gas, along with any water present, is then removed from the system through the evacuation process. This approach effectively prevents the freezing of moisture inside the system, ensuring smooth operation without the risk of clogs or disruptions.
Which gas is used to counteract freezing while evacuating system with large amount of moisture? Nitrogen.
Using a large vacuum pump accelerates the evacuation process. However, it also presents a peculiar challenge: ice formation. As the pressure and temperature decreases rapidly during evacuation, water within the system may freeze, leading to the formation of ice.
Water present in system can freeze if large vacuum pump is used for evacuation. Okay, recovery. Yeah, it can be freezed.
In this module, we covered various aspects of evacuating a system and explored tips and techniques for successful evacuation. Gaining a thorough understanding of these concepts will enhance our ability to perform evacuations effectively.
Okay, we finish evacuation. Let's go to charging, the next module.
In this module, we will cover the proper procedures for recharging a system with refrigerant.
PT charts, or pressure temperature charts, display the relationship between pressure and saturation temperature for a substance like a refrigerant. They allow us to determine the saturation temperature at a given pressure and vice versa. Consider this PT chart for R123. The value 40 degrees Fahrenheit is marked in the chart, and it corresponds to 18.1 inches mercury absolute. It means that our 123 boils at 40 degrees Fahrenheit when the pressure is 18.1 inches of mercury absolute. The red pressure values on the chart represent vacuum pressures and are given in inches of mercury absolute units. Liquid charging involves refilling the system with liquid refrigerant, which is a faster method compared to other charging methods. It is suitable for appliances that do not incorporate water in any of their components, such as air-cooled systems. However, in major Type 3 appliances that utilize water, liquid charging is not directly applicable due to the presence of water in the system components. In systems where water is present in any part or component, initiating the charging process with vapor charging becomes necessary. Let us understand why. It is necessary to evacuate a system before filling it back with refrigerant. During the evacuation process, the pressure inside the system drops significantly, typically reaching around 500 microns. At this low pressure, the evaporation point of any remaining moisture or contaminants is much lower than the freezing point of water, which is 0 degrees Celsius. This ensures that the system is thoroughly purged of impurities before refilling, preventing potential issues like freezing and corrosion. Even with temperatures below 0 degrees Celsius, introducing liquid refrigerant into an evacuated system can result in its boiling into vapor. For instance, at 0 degrees Celsius, the saturation pressure of R123 remains approximately 20 inches of mercury absolute. In the chart, the value 20 inches, around 19.5, of mercury vacuum is highlighted, and it corresponds to 35 degrees Fahrenheit. This indicates that R123 will reach its boiling point at 35 degrees Fahrenheit when the pressure is around 20 inches, around 19.5, of mercury vacuum. Remember that water typically boils at 212 degrees Fahrenheit under atmospheric pressure conditions. The refrigerant can easily boil when the pressure is around 20 inches, around 19.5, of mercury vacuum, requiring only a temperature lower than 35 degrees Fahrenheit. As a liquid boils, it absorbs heat. Therefore, during boiling, the liquid refrigerant will absorb heat from the water in the system, causing the water to freeze into ice. Melting the ice can be challenging, and in some cases, attempting to do so may lead to the rupture and bursting of the evaporator or condenser coils, posing significant dangers. To mitigate this risk, chiller systems are initially charged with vapor refrigerant to prevent ice formation and the associated hazards. Vapor charging continues until the pressure in the system reaches the level corresponding to a saturation temperature of 35 degrees Fahrenheit or 0 degrees Celsius. It's important to familiarize oneself with PT charts, as similar charts may be provided in the EPA exam, enabling technicians to determine saturation temperatures and pressures accurately.
How do you know when enough vapor has entered the appliance before you charge the refrigerant liquid? Refrigerant saturation temperature increase. Recovery unit liquid level drop at lower pressure. Vapor is charged for 15 minutes and then liquid added. Recovery unit pressure drop at lower pressure. Okay, I think this one. No, refrigeration saturation temperature more than 32. What is the risk is associated with attempting to melt ice formed in chiller system after charging with liquid refrigerant? Okay, increased energy consumption, risk of rupture and parsing coils, decreased coil, risk of this one, rupture
Charging the
and
vapor
parsing
refrigerant
coils.
from the lowest point of the system is recommended to facilitate the smooth flow of refrigerant from high-pressure cylinders to the lower-pressure evaporator charging valve of the chiller. This approach ensures efficient and effective refrigerant charging, minimizing pressure differentials and potential system issues. The evaporator charging valve is the lowest access point on all centrifugal chillers. It is the valve from where the refrigerant should be filled back into the system.
What is the lowest access point on low pressure centrifugal air conditioning appliances? Evaporator charging valve.
In this module, we covered the proper procedures for refilling refrigerant into a system. We also explored the significance of pressure-temperature relationships in this process, particularly in chiller systems.
Okay, let's go to evacuation and chiller quiz. Okay, what risk is associated with attempting to melt ice formed in chiller system after charging with liquid refrigerant? This risk of rupture and bursting coil. How do you know when enough vapor has entered the appliances before you charge refrigerant liquid? Refrigerant saturation temperature increase above 32. Identify the recovery requirement for equipment disposal. It's 25 millimeter of HD absolute. Water present in the system can freeze if. Okay, large vacuum pump is used for evacuation. Yeah. What is the lowest access point on low pressure centrifugal air conditioning appliances? Evaporator charging valve. It's the lowest access point. Which gas is used to counteract freezing while evacuating system with large amount of moisture? It's nitrogen. It's used for counteract of freezing. We answer all. Let's submit. And 10 of 10. Okay, we answer all correctly. Let's go to the next module. This is the next and the last module. So in this video we finished refrigerant recovery and evacuation and charging. Now repair and safety. Major and
In
minor
this module, we will learn
repair.
about EPA's classification of major and minor repairs.
According to the EPA, major repairs involve maintenance, service, or repair that necessitates the removal of certain components from the appliance. These components include the condenser, evaporator, auxiliary heat exchanger coil, and compressor. Any repairs beyond these components are classified as minor repairs. If there is an irreparable flaw in the evaporator or condenser coils, they may need to be removed or replaced. Irreparable flaws include issues such as rusting of the coils or a hole in the coil piping that is too large to be repaired effectively. In such cases, removal or replacement of the affected coils becomes necessary. Evaporator and condenser coils serve as types of heat exchangers within a refrigeration system. An auxiliary heat exchanger refers to an additional or secondary heat exchanger within the system. These auxiliary heat exchangers are commonly found in heat pumps and larger cooling systems designed to regulate temperature in expansive spaces. Examples of major compressor repairs include a compressor burnout, causing its replacement, a non-operational compressor due to mechanical problems, a broken or leaking compressor. We will talk about compressor burnout in more detail.
Which of the following would be considered as a major repair under EPA regulation? Replacing a condenser coil? Yeah.
A major repair in refrigeration systems involves detecting a compressor burnout, which necessitates taking an oil sample to assess its condition. An oil sample is crucial for identifying a compressor burnout, indicating damage to the compressor's motor windings due to a short circuit. During a burnout, an electrical component experiencing a short circuit generates exceptionally high voltage and temperatures, resulting in the combustion of refrigerant oil. The burnt oil acquires acidic properties, posing a threat to the system's components and integrity. During system repairs, technicians should adhere to the following steps. Isolate the component requiring repair, evacuate the isolated section to remove any contaminants, and allow a few minutes to observe if the pressure increases in the system. These procedures are covered in detail in the evacuation topic.
If a unit experiences a compressor burnout, we would collect an oil sample as a part of major repair.
Minor repairs are those that do not involve the removal of major components. In these cases, methods like heating the system using heating blankets are often employed to detect leaks. It's crucial to identify leaks before proceeding with any repairs to ensure the system's integrity and efficiency. Additionally, refrigerant recovery may be necessary before conducting repairs to prevent the release of refrigerants into the atmosphere as mandated by environmental regulations. In this module, we've looked at the EPA's classification of major and minor repairs, a crucial aspect of the EPA Type 3 course. Understanding these classifications is essential for technicians working with Type 3 appliances to ensure compliance with environmental regulations and safety standards.
Okay, let's go to safety.
In this module, we'll learn about several safety practices essential for handling EPA Type 3 appliances.
Ensure that you always wear appropriate personal protective equipment when handling refrigerants. This includes safety glasses, safety gloves, safety shoes, and a safety hat or helmet. ASHRAE Standard 15 addresses the safety of individuals and property in and around facilities with refrigeration systems. In this module, the most important part to note is the equipment room requirements. Refrigerants pose significant risks due to their toxicity, making inhalation potentially life-threatening. When refrigeration equipment is located indoors, it's essential to have a dedicated room for them. This equipment room should be equipped with electronic refrigerant detectors and a mechanical ventilation system that operates continuously to ensure safety. These systems operate by drawing fresh air from outside into the equipment room through one side and expelling room air through the other side using mechanical fans and blowers. Think of it like a larger version of a kitchen exhaust fan, but designed for industrial-scale ventilation purposes. Equipment room refrigerant detectors are electronic devices designed to detect the presence of refrigerants in the air. When they detect refrigerant leakage, they trigger an alarm to alert personnel. In addition to sounding the alarm, the ventilation systems are activated to bring in fresh air and mitigate the leak. Any detection of refrigerant outside the system indicates a potential refrigerant leak that needs to be addressed. Equipment room refrigerant detectors are also referred to as room sensors in the EPA exam. These sensors are mandatory in all equipment rooms containing Type 3 appliances, regardless of the type of refrigerant used.
According to ASHRAE Standard 15, 2013, which equipment is mandated to detect refrigerant leak? Room sensor, mechanical ventilation, pollution detector, air purifier with HEPA filter. Which equipment is mandated to detect refrigerant leak? Room sensor.
The alarm is designed to activate just before the threshold limit value, time-weighted average, is exceeded. If the detector senses any refrigerant concentration in the air above its threshold limit value, it triggers the alarm, indicating potential harm from exposure to the refrigerant. The time-weighted average represents the average limit of refrigerant exposure deemed safe for a standard 8-hour workday and a 40-hour work week. It's crucial that the average refrigerant leak over the course of the day and week remains below the specified TWA values to ensure safety.
According to ASHRAE Standard 15, 2013, which types of refrigerant leaks are room sensor and alarm required to detect? Or refrigerant safety group?
A sight glass is a transparent glass used to check for signs of moisture inside a system. During colder temperatures, ice or dirt might accumulate on the sight glass, requiring cleaning using an isopropyl alcohol spray. Isopropyl alcohol is also commonly used to de-ice car windshields during winters.
What is the main function of isopropyl alcohol in refrigerant system? To regulate pressure while evacuation, to remove air from the filter dryer, to remove ice off the side of the glass.
A rupture disc is a safety device set to burst open at a pressure of 15 psig. The discharge from the ruptured disc should be directed outdoors into the atmosphere to prevent the buildup of refrigerant in the equipment room during accidents. A relief valve protects against high pressures in the system. A common example of how it works is a pressure cooker, where the cap on top lifts to release the built-up steam when pressure inside exceeds safe levels. In the past, incidents involving boilers and compressor systems have occurred due to pressure surpassing the system's limits. The pressure relief valve stands as the paramount safety feature in such scenarios, ensuring pressure stays within safe bounds. Every refrigerating system must be equipped with a pressure relief valve to guarantee safety. Installing multiple pressure relief valves in series on system lines is not advisable. This is because installing multiple valves makes all other valves useless as all pressure is released out of a single valve. It can also lead to excessive loss of fluid, as multiple valves may simultaneously release pressure.
Which configuration should pressure valve never be installed in series?
In this module, we discuss the safety practices that need to be kept in mind while dealing with EPA Type 3 appliances. These practices are critical while performing any repair and maintenance works in any system.
Okay, let's take the quiz. Okay, attempt the quiz. Okay, we have 6 questions here. Which of the following would be considered as a major repair under EPA regulation? Replacing condenser coil. According to ASHRAE Standard 15, 2013, which types of refrigerant leak are room sensor and alarm required to detect, or refrigerant? According to ASHRAE Standard 15, 2013, which equipment is mandated to detect refrigerant leak? Room sensors. Which configuration should pressure relief valve never be installed in? Series. What is the main function of isopropyl alcohol in refrigerant system? Is to remove ice off the sight glass. If a unit experiences compressor burnout, we would collect an oil sample as a part of major repair. Let's check the answers. We answered all the questions. Let's see the result. The result is 10 of 10. Okay, so we finished here. Today we finished repair this refrigerant recovery and evacuation and charging and repair and safety. Okay, so we finished by this way type 3 and we are ready to enter the exam of EPA 608 Universal Certificate. Thank you.